Guys, we are going to start looking at some proofs. So geometric proofs, we are going to use given information along with properties of algebra, technically properties of equality, postulates, theorems, and definitions to show that other statements must be true. So any theorem you've learned, any postulate, any definition you've learned, our properties that are stated above, we can use all of these in our proofs. And I will be providing you with kind of a list, like a resource of all our definitions and such, sometime this week to kind of help you just have all that information in one place for our justifications. Proofs are also often written in 2-column format with statements and then reasons. So this is our general layout. When you're doing your proofs out of your textbook, obviously you won't necessarily be given a little chart like this, but when I'm making a document, this is how I like to organize it. You can also make it almost like a little T-chart. Don't feel like you have to do a big box with lines and stuff. If I was going to write one out by hand, I would just do a little T-chart, statements on the left, reasons on the right. Now, our statements are our mathematical or our geometric statements, like our equations. Our reasons are always going to be definitions, postulate, theorems, and properties. So we're going to make a statement on the left and explain why we can make that statement on the right. And the 2-column format is used often because it's like steps. You're given one thing. Okay, what does that tell you that can lead you into step 2? Now that what we've said in step 2, what do we know that can lead us into step 3, and so on. So first, we are going to look at a proof that involves some segments. Okay, so we're going to use this picture as a reference as well. This is our given information. This is what we're being provided with as a starting point. And this is our prove, which is basically our conclusion. This is where we want to end up. So we are given that segment RT and segment PQ are intersecting at point S, so that the measure of RS equals the measure of PS, and the measure of TS equals the measure of SQ, which is nicely labeled for us in our picture. If you're ever given a picture and it's not pre-labeled, I would make sure you do that. We want to prove that segment RT, the measure of RT is equal to the measure of PQ. So RT is this full segment here. We want to prove that that's congruent to our other full segment, PQ. Okay, now if you take a look, before we even start writing anything down, just think logically about this picture. If it helps you, assign some numbers to it, just generically to help us out here. Let's say I said the measure of RS was 5. Well, I know that that's congruent to the measure of SP, which would also then be 5. Okay, then let's just say hypothetically the measure of QS was 7. Well, I know that the measure of ST is the same, so that's also 7. And if I add those parts up, the measure of RT would be 5 plus 7, which is 12. And the measure of PQ would be 5 plus 7, which is 12. Therefore, the full measurements are also equivalent. Now, if you guys saw that with numbers, you'd be like, yeah, of course, 5 plus 7 is 12. We're going to do that same exact strategy, except instead of actual numbers, we're just given their labels, right? The measure of RS. So let's take a look at our 2 columns now. Okay, so our first statement is always our given. We're just going to restate it. So we are told that segment RT and segment PQ intersecting at point S, so that the measure of RS equals the measure of PS, and the measure of ST equals the measure of SQ. And our first reason is always just given. How do we know? It was given to us. Now, our last statement is always going to be our proof. We're trying to prove that the measure of RT equals the measure of PQ. We don't know quite why yet, but that's where we need to get. Now, if I'm giving you a table and you can see, okay, this is going to have 4 steps, then you automatically know to put in that 4th step, your proof. The measure of RT equals the measure of PQ. If you're writing one independently, you might not quite know how many steps it's going to take, but you can always kind of put that towards the bottom as you work your way there. So now how are we going to possibly prove that the entire measurement of RT equals the entire measurement of PQ? Well, think about what I said before with the numbers. Segment RT is made up of our 2 smaller parts, segment RS and segment ST. Same idea is happening with segment PQ. And we know we have a bunch of equivalent or congruent segments here. So the first thing that we need, and you can do this in more than one order, okay? So there are typically multiple ways to do this. But I would probably go ahead and start by adding some parts of our segments together, right? We know that the measure of RS is equivalent to the measure of PS. We also know that the measure of QS is equivalent to the measure of TS. Well, so what if I took those measurements and I added them to either side? According to our addition property, we're allowed to add equivalent measurements. So if I start with an equation, technically this is an equation here. Measure of RS equals the measure of PS. Well, what if I took my measure of RS and I added the measure of ST to it? Well, that means on the other side, I still have my measure of PS, but I'm allowed, according to my addition property, I'm allowed to add an equivalent value. Well, the equivalent of SQ is equivalent, I'm sorry, the measure of SQ is equivalent to the measure of ST. So I could add the measure of SQ to either side there, right? I had some equivalent values up here. So I am allowed to add them to either side of my equation. So I added these to either side of my equation that RS equals PS. I'm adding something to both sides, so that is the addition property. Okay. Now, why is this helpful? Well, if you look, I now have my full segment paired together. Measure of RS and the measure of ST is going to make that whole measurement, right? And the measure of PS plus the measure of SQ is also going to make that entire measurement. So that's helpful because that's where we want to end up. We want to end up with our full segment. Okay, so now where can we go from here? Well, again, we need to mention RT and PQ in some way because we have to end with that statement. The measure of RT equals the measure of PQ. Right? If that's where I want to end, at some point before then, I have to mention them. They're not just going to magically appear in my proof. Well, if you look at step 2 here, right, if I know this information, right, what else can I say? Well, I have here that the measure of RS plus the measure of ST, right? Well, if you look at your picture, that's your whole segment, right? My larger segment is made up of those 2 little parts. So that's a way to introduce the measure of RT into my proof. I know that the measure of RT equals So I know that the measure of RT equals the measure of RS plus the measure of ST, right? I can see that from my picture, and I was told that I have those segments in my given. Well, I can do that same thing on the other side. I know that the measure of PQ equals the measure of PS plus the measure of SQ. Now think back to our properties that we've learned. Is there a property out there that, or a postulate or a definition or a theorem that lets us take smaller parts of a segment and add it up to the whole? Absolutely. That is the segment addition postulate. Right? The segment addition postulate lets me say that one part of my segment plus another part of my segment equals the entire segment. So that allowed me to introduce segment RT and segment PQ into my proof. They needed to be featured because they're the entire point. That's where I need to get to. Okay, so now how am I going to go from 3 to 4, right? If I know all this information above, then how is that going to help me say that the measure of RT equals the measure of PQ? Well, if you look up above at step 2, I know that the measure of the measure of RS plus the measure of ST equals the measure of PS plus the measure of SQ, right? Don't I? I know that these two statements here are equivalent. I said it in the step above. Well, if these two statements are equivalent, won't these two statements also have to be equivalent? What I can do here is substitute one in for each other. Again, they're equivalent. So then I can say RT is then also equivalent to PQ. So that is the substitution property. Right? Again, in step 2, I stated that this is equivalent to this. Therefore, according to the substitution property, the measure of RT would also have to be equivalent to the measure of PQ. Again, think of these as little if-then statements. If I know this, then what do I know? If I know that, then what do I know? And so on. And these will become a little bit clearer as we go through and do these. So now let's look at something very similar, but this one has to do with angles. So number 2 says we are given that the measure of angle AOC is equal to the measure of angle BOD. We want to prove that angle 1 is congruent to angle 3. So this is where we want to get to. Angle 1 is, the measure of angle 1 equals the measure of angle 3. So again, look at your picture. Let's not worry about this yet. Look at your picture. Look at your clues here. Angle AOC and the measure of angle BOD are equivalent, right? We want to end up with just angle 1 and 3 being equivalent. Well, if you look at your picture, don't both of these angles share angle 2, right? The larger angles, they both share angle 2. Angle AOC is made up of angle 1 plus angle 2. Angle BOD is made up of angle 2 plus angle 3. They both have angle 2 in them. Well, imagine if we took angle 2 and we removed it. Well, then we would be able to say that the measure of angle 1 equals the measure of angle 3. So we're going to go through and do that, but we need to give justifications with each step. So let's start with our given. The measure of angle AOC equals the measure of angle BOD that is given to us. So our reason is given. We want to end up with saying that the measure of angle 1 equals the measure of angle 3. We just got to figure out how to get there. So think about what we did in our last proof. Our larger segments were made up of smaller parts, right? So we used the segment addition postulate. Well, we can use some similar strategies in this one, just using angles. If you look at angle AOC, it's made up of two smaller parts, angle 1 and angle 2. Well, since I need to end up with the measure of angle 1 and the measure of angle 3 at the end of my proof, that means I need to mention them in some way. I have to figure out a way to get them stated in my proof. Well, if I have larger angles that are made up of smaller parts, I can break those down And that could be how I start to mention angle 1 and angle 3. So if you look at angle AOC, we're going to take that and break it into its smaller parts. All right, the measure of angle AOC equals the measure of angle 1 plus the measure of angle 2, because those are our smaller parts. And then we can do the same thing for the measure of angle BOD, and we're going to say that equals the measure of angle 2 plus the measure of angle 3. And then remember, when we're taking smaller parts of angles and adding them up to create a larger angle, that is the angle addition postulate. So that's our reason. Okay. Now we somehow need to get the measure of angle 1 equal to the measure of angle 3. That means we need to figure out an equation that we can write that involves both of these components. Well, if you look at your given, we know that the measure of angle AOC is equal to the measure of angle BOD. So if these are equivalent, then we can set these parts equivalent as well. So again, in your given, we know that the measure of angle AOC equals the measure of angle BOD. So then we're going to set their smaller parts equal as well. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And what allowed us to do that was the substitution property. Now we have this equation, but we don't want all of this. We just want to be able to say the measure of angle 1 equals the measure of angle 3. So how can we get from step 3 to step 4? Well, somehow we got to get rid of the measure of angle 2. Well, if you look, we're adding the measure of angle 2 on the left, and it's being added on the right. And if we use our subtraction property, we can subtract out the measure of angle 2 from either side, and we would just be left with the measure of angle 1 equals the measure of angle 3. So to get from step 3 to step 4, we would subtract, so that is the subtraction property. Okay. So then the next ones are similar to the ones we've already done, just kind of flipped around a little bit. Number 3 says the measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4. We want to prove that the measure of angle ABC equals the measure of angle DEF. So it's kind of like the one we just did, but flipped around. This time we're given smaller congruent parts, and we want to use those to show the entire angles are congruent. So let's first put in our given. The measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4. That's given. And we're trying to prove that the measure of angle ABC equals the measure of angle DEF. So we know that we need to somehow mention angle ABC and DEF in our proof, right? That's where we need to end up. So somewhere they're going to need to be mentioned. Now, how could we bring those up? Well, we're given information about our smaller parts here. So we should know at some point we're going to have to add up our smaller parts to make a whole. Another thing we're going to need to do is, since we're going to have to add up our smaller parts, we need to get all of these things in one statement together. Right now, they're kind of split up, right? Measure of angle 1 is with measure of angle 3. Measure of angle 2 is with measure of angle 4. How could we maybe combine those things together? Well, if we know that measurements are equal, we could use our addition property to add it to either side of our other equation. So what we're going to do is say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Again, we know based on our given that measure of angle 2 and the measure of angle 4 are equivalent, which allows us to add them to either side. Now, what that let us do is it let us start to kind of combine our parts, right? We now have one larger expression rather than two separate parts. Now that everything's kind of tied together, we can work with it to get our full angle. And the reason we were able to do this step is the addition property. Okay. So now that we have those parts combined, we need to now rename these. We need to be able to say the measure of angle ABC and the measure of angle DEF. Well, now that we have angle 1 and angle 2 kind of tied together, if you look at your picture, we can see the measure of angle 1 and the measure of angle 2 is going to give us that full angle there, ABC. So let's use our angle addition postulate to rename that. So we're going to say the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2. And now we can do the same thing with angle DEF. So the measure of angle DEF equals the measure of angle 3 plus the measure of angle 4. Again, we needed to find a way to introduce our full angles into the proof. So that's why we use our angle addition postulate. So now somehow we're done. We just have to figure out what was the justification. What would allow us to say the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2, and the measure of DEF equals the measure of angle 3 plus the measure of angle 4. And that's enough to say that the measure of ABC equals the measure of DEF. Well, if you look at step 2, we knew in step 2 that the measure of angle 1 plus the measure of angle 2 is equivalent to the measure of angle 3 plus the measure of angle 4, which means by our substitution property, we can say the measure of ABC is equal to the measure of angle DEF. So that is the substitution property. Okay, so again, that was very similar to the one we did above, just maybe a little in a different order, different information given. Also very similar to the segment one we did on the other page. And then the last one. So this, number 4, is very similar to number 2, except it's dealing with segments instead of angles. Here we're given that the measure of ST is equal to the measure of RN. So those are our full segments. And the measure of IT is equal to the measure of RU. So those are our little parts here. We want to prove that the measure of SI is equal to the measure of UN. So those are the other little parts. So very similar to what we did in number 2. We know our full segments are congruent. We know another little chunk inside of here is congruent. How are we going to show the other chunk is congruent? Well, again, think of this with numbers. Think of it numerically. If I told you the measure of ST was 10 and the measure of IT was 3, and I told you the measure of RN was then also 10, because we know they're equivalent, and the measure of RU was also 3, if we subtract 3 out, that means both of those parts are going to equal 7. So we can kind of use that same logic there, just with our labels instead of actual numbers. So let's write down our statements. The first thing is our given. So the measure of ST equals the measure of RN, and the measure of IT equals the measure of RU. That is given. And we want to prove that the measure of SI equals the measure of UN. So we need to introduce the measure of SI and the measure of UN into our proof. They are not mentioned in our given, so we need to find a way to introduce them. Well, one way you could start to introduce those, and again, there might be more than one good order to do this, so if you think of something different, that's totally fine. But how I'm going to introduce these is actually by taking my parts here and showing that the measure of SI plus the measure of IT equals my whole measurement, right? We already mentioned ST and RN. Well, what about their smaller parts? That's a way to introduce that into our proof. So I'm going to say that the measure of ST equals the measure of SI plus the measure of IT, right? My whole segment is equal to my smaller parts added together. And now I can do the same thing with RN. So the measure of RN equals the measure of RU plus the measure of UN. And remember, that is our segment addition postulate that allows us to add up those smaller parts. Okay. So now we've introduced the measure of SI and the measure of UN into our proof, but how are we now going to show that they are equivalent? Well, in our given, we were told that the measure of SI equals the measure of RN. And those measurements are again mentioned in step 2. So if these measurements are equivalent, that means we can then set the right-hand sides equivalent as well. So the measure of SI plus the measure of IT equals the measure of RU plus the measure of UN. And what lets me do that is the substitution property. Okay. So now we're almost there. We have the measure of SI on the left. We have the measure of UN on the right. But how are we going to show that just these two parts are equal? Well, we got to figure out a way to get rid of the measure of IT and the measure of RU. Well, again, in your given, we were told that those are equivalent. If you have something equivalent on the left and on the right of an equation, we can get rid of those by subtracting them out, right? They're being added in on the left, added in on the right, get rid of them by subtracting them out. Our subtraction property allows us to subtract equivalent things from both sides. So that is the subtraction property. And that's it for our proof examples today. You're going to have some in your homework and then probably one on the content check. Let me know if you need any help with anything. And again, when you're writing them freehand, you can just do a little T-chart if you don't want to have to make a table. And you should make sure you get this done by class on Tuesday or Wednesday. Monday, we're going to be doing something else. Have a great day.